All right, let's talk about intersection types in Kotlin. Kotlin's type system does actually support intersection types. What it doesn't support is intersection types that are denotable, with one exception, and that is the definitely non-nullable types, which I'm not going to talk about today. So we'll ignore those for today. Maybe we can cover those another time. But when I say that Kotlin doesn't support intersection types that are denotable, what I mean by that is that you and I as developers, we can't write them out in the code. And so in other words, we can't declare a variable that has a type that's an intersection type. We can't declare a function parameter or a function return type that is an intersection type. But we can still create scopes where they exist. And that's what we're going to do today. So for those who aren't familiar with them already, an intersection type is really just a type that is at an intersection of two or more types. So if you have, for example, a type called named, which has a name property on it, and you also have a type called addressable that has a URL property, then an intersection type for those two can be thought of any type that is both named and addressable. And there's a more technical definition to this that involves like overlap of sets of values that each of these types can represent. We'll save that for another time. But for today, we'll just consider them to be a type that is comprised of two or more other types. And you typically would see them notated as, for example, named and addressable. So named ampersand addressable. So here I've got two interfaces. I've got one called named and one called addressable. And I've also got a couple of classes here. You can see we've got a class for user and a class for product, and both of these classes implement both of those interfaces. And then over here on the right, I've got a couple of objects that I created from these two classes. One is an example user and one is an example product. And we're just going to use that to be kind of our example data so we have something to work with here. Now over here, I've got a function where we want to process an object that has both the named and addressable types. And in a language that fully supports denotable intersection types, like TypeScript or maybe Scala, we could say named ampersand addressable, and that's it, and you're on your way. But since they're not yet denotable in Kotlin, this isn't going to work. So if we can't declare the type of this parameter to be an intersection type, how can we actually use intersection types here? So I'm not saying it's great, but one option, it's an option, is to simply set this parameter type to any, and then inside this function, we can use a conditional to check the type. So we could say item is named. Now remember, when we do this, Kotlin's going to do a smart cast for us, and so that means inside this conditional block, item is now going to have a type of named. Now, here's where Kotlin support for intersection types can come in. So if we also check to see that this same object is addressable, then Kotlin's going to do another smart cast on that as well. And now inside this conditional, item's been smart cast to two different unrelated types at the same time. So here, if we do item dot, we can see it's got both the name and URL properties on it. And if we hover here, we can see it's been smart cast to named. And if we hover over here, we can see it's been smart cast to addressable. So inside the body of the if statement, item is an intersection type. It's got both named and addressable. We still can't specify the intersection type in here. So for example, if we were going to try to assign this to a new variable, just call it X, and ask the IDE to specify its type explicitly, the type is going to be any. And we can check the properties and functions on this guy, and we can see it really just has whatever any would have. But if we don't explicitly specify the type, then it actually preserves the intersection type. So if we take this off, then in here we can see that it has also, we can see it has the name and URL properties on it. So this is a case where you really can't explicitly specify the type and preserve the type that it is because it's not denotable. So this works, but I don't love it, right? Because we're checking the type of our argument at runtime. And if it doesn't match what we want, then this process function is basically going to be a no-op, meaning that it's just not going to do anything. So in other words, we can literally pass this thing anything other than a null, and this function is going to receive it. But it will only do something if this conditional matches. So we can pass like process 1, 2, 3, 4, and that compiles just fine. We can do process string. And this approach, like it might be okay if all we're doing is logging. You might be able to convince me of that one. But if we're actually going to fetch the URL here, the object at this URL, and process it in some way, as the name of this function implies, then a runtime check is going to be a lot less helpful than a compile time check, right? It almost always is. So we can do better on this. Let's start by removing this conditional. And next we'll make this a generic function. So instead of accepting a type of any, we're going to put our type parameter here. We declare it right here. And then now this is worse, of course, right? Because before it was accepting anything, literally anything except for null. And now it's accepting anything including null. So we'll fix that here in a second. Let's fix this by adding a type parameter constraint. So this is going to tell Kotlin that the type argument for this can only be named or one of its subtypes. And so far you can see the errors down here, they look like we want, but this item doesn't have the addressable type. And so that's why we're not getting the URL property, why it's not getting found there. Now, it's not quite as well known, but one of the things you can do is specify more than one type parameter constraint. And to do this, instead of specifying the constraint over here in the diamond on the left-hand side, we're going to take that out and we go over here to the right and we type the word where, we say t:\named, and then we can just add a comma and add another type parameter constraint. So we'll just say t:\addressable. And with this, we've got an intersection type inside this function, and it's compile time checked. So you can see these arguments down here that we're getting in the front door before are not allowed anymore. And again, all this happens at compile time, which is fantastic. So sure, this is a cool trick, right? But if you're like Mr. Grumpy or Recalcitrant Man, you might be saying, Dave, why I got to use intersections when I can just mushy mush them interfaces? And in many, if not most cases, I think that's probably the most natural solution. So for our code, for example, we could just create an interface to inherit from these two interfaces, compose them together. We can update the class to inherit from that. And the function then would receive an argument of that type. Now the type hierarchy that I used as an example in this video obviously is pretty simple, right? I could easily envision more complex configurations for type hierarchies where it would be more difficult maybe to insert an intermediate type that could be used as a replacement for an intersection type. I could also see cases where these types are not part of your project, but they're in a library. And so you don't actually have a way to insert a type in there to use interface composition. Anyway, what do you think? Are you interested in having first-class denotable intersection types in Kotlin? Let me know in the comments, and I'll see you next time. You've read the chapters online, and now I'm proud to present the Lean Puff edition of Kotlin, an illustrated guide. Take the book offline with you, mark it up in your favorite PDF software, and get early access to new chapters as they're written. You can pick up your copy today. Just go to book.typealias.com.